Okay, so to start off this lesson, we're looking at transformations of graphs. So a transformation is just a change. In geometry, there's actually a whole train of thought known as transformational geometry, where you look at figures that are reflected, rotated, given a slide, which is also known as a translation, dilated, where it's like expanded or given a shrinking factor. So with graphs, we can look at actually 5 types of changes here I've listed on the left. There's a vertical translation. That's also known as a shift, and vertical just means up or down, so you can slide a graph up or down. Horizontal translation, shift it left or right. A vertical, like stretching or shrinking factor, and a horizontal stretching or shrinking factor. And the other thing is you can reflect them. So a parabola might open up, you can reflect it so it opens down. Over here, this image can also be found within the module, but any generic function, so this f of negative x plus h, that could be parentheses squared, it could be absolute value, and I'm going to show you an example in a moment, but it's labeled here with the different changes. So adding and subtracting this plus h plus k, that's what's going to slide the graph up and down or left and right. You can see that there in the image. Multiplying out in front is your vertical stretch or shrink. Now if you notice, there's nothing about a horizontal stretch or shrink. That's because they're closely related. So multiplying on the outside versus multiplying on the inside can actually alter either direction, shrinking up and down or left and right. And what I think of is I think of like Play-Doh or like a kid's toy like that. And if you think about it, when you stretch something vertically, it kind of shrinks horizontally because you're stretching it out. Or if you stretch it horizontally, it would get flatter, it'd be shrinking down. So those stretches are very closely related. Notice stuff in parentheses, that's left-right changes. Things outside of parentheses, those are up-down changes. Addition's a slide, multiplication is a stretch or a shrink. And then if you notice the 2 negatives are labeled, putting negatives inside parentheses with the x is what reflects over the y-axis. Putting negatives outside is what reflects over the x-axis. So it's actually a lot easier to see this in practice. And with the touch screen, it's a little tough with drawing with your finger or drawing with the apparatus that I forget what it's called. But we're going to go to desmos.com and use the graphing calculator there. So let's start with x squared. So I'm going to come in here and I'm going to graph y equals x squared, and we've got a parabola. Now watch what happens if I do y equals parentheses x minus 3 squared. What it does is it shifts it to the right. Now if I come out here and I add, say, 2 on the outside, it actually shifts it up 2 at the same time. I'm going to put a new one in here. What if I take that original y equals x squared and I put a 3 in front of it? 3x squared. If you look, it looks like it's shrinking horizontally. What's actually happened is it's being stretched vertically by a factor of 3. That's that idea of when stretching vertically, also it's like Play-Doh, it's going to shrink horizontally when you do that. So you can make all those changes at once to the one above. I can put a 3 in front of that, and it shrinks it down horizontally because it's stretching it vertically. One more, let's look at a negative. So if I put a negative out in front, negative x squared, what we've got is we've got it reflected down. And again, I can do that with any of them. So I'm going to put that up here in the front. We've got all the changes happening now. We've got a negative that's reflecting it down. We've got the 3 that's stretching it 3 times as tall. We've got an x minus 3, and if you noted that in the image, negatives shift right, positives shift left. And then we have the plus 2, and that shifts the way you'd expect, so that goes up too. So parabolas are very common to do this with, and the other thing, which we'll look at real quick, is absolute value. So if you use absolute value, you get a v. So what if we put it in absolute value and we add 4? Well, it shifted to the left 4. Outside the absolute value, what if we subtract 3? It shifts down 3. What if we put a 2 out in front? stretches it up twice as tall. What if we make that a -2? Flips it down. Now what if we put a negative inside here? It reflected it over the y-axis also. So Desmos is a great place for you to play around and get an idea of how these various transformations happen.